Hello and welcome to On Semiconductor's webcast. Today we will discuss the advantages of Alliance for Wireless Power, or A4WP technology, called resonance. In the wireless charging overview, we describe the advantages of Alliance for Wireless Power, or A4WP technology called resonance, versus the first generation technology from Wireless Power Consortium, or WPC, and Power Matters Alliance, or PMA. These advantages include the ability to charge through surfaces, which makes it convenient to be installed under tabletops or countertops and be invisible to the end user. The wireless charging module would also offer multiple power levels of charging and charging multiple devices at the same time through the same pad. It also can charge in the presence of metal objects such as coins and keys. Finally, it uses Bluetooth Smart, which is a standard communication protocol used in most portable devices these days. The Bluetooth Smart is for object detection and charging pad and object handshake as an indicator to start charging. The A4WP ubiquitous power vision is based on spatial freedom while charging. The ability to charge multiple devices over a wide area through a single charging pad or transmitter. This also includes the ability to charge the device without alignment in any specific direction with the charging pad. It is also the ability to charge over distances from the charging plane and through surfaces. In other words, the A4WP vision for ubiquitous power is too good to be true. So in the following slides, we will take a look at some of the technologies that make this vision of wireless charging possible. The A4WP wireless charging solution block diagram is shown here. There are two main blocks in the wireless power transfer WPT architecture: a power transmitting unit, PTU, and a power receiving unit, PRU. The PTU and PRU communicate with each other via the Bluetooth Smart or Bluetooth Low Energy, or BLE protocol, at 2.4 GHz frequency. After the communication, a handshake is established. The power will then be transferred from the PTU to the PRU over 6.78 MHz frequency. So remember, the communication is at 2.4 GHz and power transfer is at 6.78 MHz. This scheme, where communication between the TX and RX side is done via a secret frequency range, then the power transfer frequency range, is called out-of-band communication. A4WP utilizes this scheme, which is different than WPC and PMA schemes, where communication is done on the same frequency as power transfer, and this is called in-band communication. On either side of PRU or PTU, there is a need for a BLE chip, and also a controller, as well as power conversion and conditioning. The PTU controls the power being transferred through the TX resonator coil through a power amplifier or PA. The PA is required to control various power transfer levels depending on how many PRUs are present at the same time on the single PTU. As indicated, this is one of the advantages of this technology, and because of this, the PTU can transmit just enough power to cover the power requirement of the total PRUs present. The PRU receives the power as an AC signal and will need a rectification circuit to convert it to DC, and then conditions this DC signal to be used to charge the battery. In A4WP Baseline System Specification, BSS, the PRU power levels are called categories. In the release standard, BSS v1.2, the PRU specifications were completed for categories 2 and 3, which cover wireless power transfer for smartphones, or 6.5 watts of received power post the inductor coil. This will allow 5 watts of power delivered to the battery, assuming efficient power conditioning. The other categories will be covered in later specifications and will be described in more detail on a following slide. In A4WP Baseline System Specification, BSS, the PTU power levels are called classes. Note that specifications follow categories for PRUs and classes for PTUs. In BSS v1.2, the PTU classes cover wireless power transfer class power from 10 watts up to 25 watts. The PTU is also specified by what category of devices it can charge at the same time on the same TX mat. For example, Class 4 can charge, by definition, 3 devices of Category 1, or 3 devices of Category 2, or 3 devices of Category 3. It also can charge only 1 device of Category 4. The other classes are still being worked on and will be covered in the roadmap slide. The A4WP relies on something called star topology of networking, which means multiple receivers can communicate at the same time with a single transmitter. The communication is described as out-of-band communication scheme. It is also bidirectional, where the PTU and PRU communicate to each other before, during, and after power transfer. As indicated before, it uses Bluetooth Smart, or BLE. And Bluetooth SIG, Special Interest Group, has assigned a profile for A4WP charging scheme. With this profile, or Universal Unique Identifier, UUID, there is no need for manual pairing, and communication is done seamlessly without the end user's input. ON Semiconductor has joined the A4WP standard during late 2013, and since then, we have been active in contributing to the standard, as well as in hosting the A4WP standard events. We offer products satisfying A4WP standard shown here. For more detail regarding ON Semiconductor wireless application, please contact your local ON Semiconductor sales representative or authorized distributor, or please visit us on the web at www.onsemi.com. Thank you.